minus H4, which is 30.5, times 1 divided by the specific volume is 0,816. That gives us a value of 28,66 kilowatt. Because remember, it is in kilojoules per second, which gives us 28,866 kilowatt. The next recipe point is recipe point number 13. You determine the energy to provide for latent heat removal and that is equal to the Q of your latent heat is going to be Q supply. Now please don't get mixed up. Don't use the Q of the outside air. That's why I've said Q supply, and the other one was QOA, which is Q of the outside air. Don't get mixed up between the two of them. Okay, Q supply times. Now remember, we're looking at latency. Latent works on the y-axis. Okay, so in other words, we're going to be looking at H3 minus HX. H3 minus HX times 1 divided by the specific volume at 4. And we know what the Q supply was, 1,376. Times H3, 56, minus HX was 47.5, times 1 divided by 0,816, gives us a value of 14,33 kilojoules per second, which is equal to 14,33 kilowatts. So now the total energy, this 14, so your total energy input into the coil has got to be equal to whatever your energy used to for the sensible heat removal, which is 28,66 kilowatts plus 14,33 kilowatts gives us 42.99. So let's say 43 kilowatts of energy has got to be fed into that coil to effect that amount of cooling from a value of 33 degrees down to 24 degrees. Okay. Now the next thing that I normally ask is how much moisture is going to be lost, because here we go back to that thing. You'll see there's the coil, and you'll see I've drawn some drips of water coming out. It's normally of interest to know how much moisture is going to be lost during this transfer of heat. Okay, so we got recipe point number 15, the amount of water that is shed. The amount of water that is shed, so the volumetric amount of water is equal to the volumetric of your supply air. And again, it makes sense because you're not going to work with outside air over there, because you want to know, that is the point of interest, is all that air that's coming from outside and coming back from there. That is going to affect the amount of moisture that you got in, the amount of moisture that's in the air. Q supply times, remember, we are working again, now we're working with moisture. And remember, when we deal with anything with regards to moisture, we're dealing in that plane. So we're going to be looking with that, using the moisture content on the side over here, okay? And we've got the moisture content at 0.3 minus the moisture content at point X. And yeah, you can add in, obviously you'd get yourself another point for this, or another mark in the exam for this thing, because you're going to draw this thing in over here. And you're going to say that the moisture content at X is equal to 0,007, 0,0072, 0,0074. So it is 0,0074. So it's going to be Q supply 1,376. Oh yes, and of course we're going to multiply it again by the specific volume at 0.4. And we said at W3, 3 at 0.3. Sorry guys, we also got to add in this one over here at 0.3. So there we go. Add that in. And this is, oh, yeah, I'm glad that I'm actually glad that we're dealing with this one, because this is going to point to that error that I mentioned earlier on that can occur. There's at 3. It is equal to 0,010, and we got 246. 0,0106, not 0,016. Okay, just remember, because if it was 0,016, it would be right up over there, and we're at 0,01, and we're on the third gradation over there, which at times 2 is going to give us 0,0106. So it is 0,0106 minus, and WX we said was 0,0074. 0,0074. Multiply that by 1 divided by 0,816. Give us a value of 0,00539 kilograms of water per second. So if we got to multiply that per hour, so multiply that by 3,600, that gives us 19,42 kilograms of water per hour, which works out at 19,42 liters per hour. And that is how much you can get out of that system. That's how much you would have to drain away. So if you had to ignore that, and that filled up inside of your sealing void, if you didn't have adequate drain on your evaporator, and you left that running for 8 hours times 8, you'd have 155 liters of water inside your sealing void. And if you didn't clear that in 5 days, you'd have 777 liters of water sitting up there, almost a ton of water ready to come crashing down. So that's why we are interested in this type of thing. Okay, right, I'm going to stop for 5 minutes so I can just restore my voice, and then I want to come back just to deal with that swivel point again. Right, till later.